So here in this video, I'll be demonstrating some other circuits I've created. Those circuits are my decoder, encoder, priority encoder, as well as my multiplexer and shifter. So I'm going to go ahead and just get started with my decoder. So off the bat, I will let you know that there seems to be something wrong with my decoder. I went ahead and I tested it internally, and it's still outputting. It outputs as true, but there's no error, which is kind of a conundrum, and you'll see that come up. But regardless, a decoder is a circuit. It's going to accept a binary input right over here, and it'll produce an output in some other form, that other form being in its minterm. So Q0 will represent x prime, y prime, z prime, Q1 will represent x prime, y prime, z, so on and so forth. So I'm going to go ahead and just work through the active high outputs truth table. So when all the inputs are 0, Q0 is going to output as true, or as high. If 001 is triggered, it's going to output Q1. 010 will output Q2. 011 is going to output Q3. And 1004 is going to output, it's going to trigger this right over here, but it is going to output as an error. And I will walk through the internal circuit I have created as well, just to kind of show what's going on, and everything seems to be connecting properly. I just don't know what it is about this right over here. But moving on, after 4, I'm going to go to 5. So 101. It's going to get me Q5, 110, Q6, and 7, 1, 2, 3. So let's go into my circuit over here and just run through all that one more time. As you can see, I already have 1004 set up and outputs correctly right over here. Everything seems to be connected. I have a Z prime, Y prime, and just standard X connected into this AND gate. For some reason, it is just outputting as an error in main. But I have 1, 2, 3, 4, 5, 6, and 7, which we cannot see. There we are. And right here I have my encoder. So the encoder will convert from some other form to binary. So right here I have my 3 outputs, and the outputs are going to represent the number of the active input line. So D1 is going to represent 001, D2 010, D3 011. Let me show you. Okay, so if I trigger D1, it's going to output 001. Awesome. So if I have D2, 010. Okay. D3 is 011. D4 is 100. D5 is 101. D6, 110. And D7, all outputs triggered. Sorry, I'm happy I finally have the binary numbers down. But that's my encoder. Let me go and show the internal structure of it. Here we are. It's not labeled correctly at all with its inputs, but it works just the same. You get 1, 2, 3, 4, 5, 6, and 7. Back to main. Following my encoder, I'm going to go ahead and demonstrate my priority encoder. If I can scroll upon it correctly. So with the priority encoder, the highest priority input is going to be what is outputted. Lower inputs are going to be ignored. So this here is a 4x2 priority encoder. So let me just go ahead and run through the truth table. So I have 001 will output 01, x0, y1. Okay, if I have D2 triggered, as well as D1, it's going to ignore D1 and output 1, 0. And if I have D3 triggered, it's going to disregard these two, D2 and D1, and output 1, 1. And let me just go ahead and demonstrate the internal structure of my priority encoder. Which is right here, works just the same since it's just decorated when it's in main. So 001 output is 01. Keep that on. D2 needs to be triggered as well, and it's going to turn into 1, 0. And if all inputs are on, it's gonna go ahead and produce 1, 1. So here I have my multiplexer circuits. And it is a 4 to 1 multiplexer, so that means I have 4 inputs, but only one gets to leave. So the selected inputs will output depending on which S switch I have on. So right now, both of the S switches are off, and since they're both off, only one of these inputs gets outputted, and that input is going to be A0. As we can see here, I will go ahead and just trigger the other inputs, and it shows that only A0 is assigned that transmission. It'll be transmitted if these are both off. But if S1 is off and S0 is on, only A1 will be outputted. Let me go ahead and go through the motion. A0 will not output, A1 will, A2 won't, and neither will A3. And if I have S1 triggered and S0 off, it is A2 that is going to be outputted. And if both switches are on, only A3 will be outputted. There we are. Let me just go and show my internal structure. So I have it upside down, but still works just the same. So that gets outputted, and this gets outputted. Okay, and there's my multiplexer. So next, what I will be demonstrating is my shifter. So bit shifting is useful for, of course, it is in its name. It can shift the bits left or right. So let me go ahead and just demonstrate it. Here I have a simple shift 1 left or right circuit. So depending on how this is triggered will depend on where the bit goes. So I'm going to go ahead and demonstrate right here. So if I trigger A3 as well as A0, I have 1 0 0 1 0, and if I flick this on, it's going to switch that binary up 1, that number over here in its output. Let me just go ahead and show the internal structure. And it's the same thing as I have out there. If I trigger this, it'll move it up and down.